This is the free response problem 1. That's from the 2013 AB calculus test, problem 5. Let f of x equal 2x squared minus 6x plus 4 and g of x equal 4 cosine of 1/4 pi x. Let R be the region bounded by the graphs of f and g as shown in the figure above. Well, actually here it's to the right. Find the area of R. Well, first identify f and g and what's above and below. If we just take a look here, the cosine function is going to be this upper curve, and so we're going to say that that is our g, and our quadratic function that opens upward is going to be our f below. And so region R is the area that I'm shading in red here. Okay, there it is. And our area is going to be set up by the integral of the top minus the bottom. So area is going to be, and our limits of integration are going to be from 0 to 2. So we have 0 to 2, and we're going to have g of x minus f of x dx. And now fleshing this out with what the real values are for these, we have from 0 to 2. We're going to put the top function, which is 4 cosine 1/4 pi x, and we're going to subtract the f function, which is 2x squared minus 6x plus 4, and that's going to be dx on the outside. And if we were on the calculator portion of the free response, we would be just fine putting this in the calculator, but we cannot do that since this is a non-calculator problem, so we need to actually integrate this. So coming down below here, we have the area is equal to, we have 4, and the integral or antiderivative of cosine is, I have this little thing to help with SC, which is called Snow Cone Santa Claus. If we go ahead and take the antiderivative in the counterclockwise direction, the antiderivative or integral of cosine is sine. So we're going to make this, I'm going to put a parentheses here for reasons I'll show you soon. We have the sine, and the sine of, I'm going to say pi x over 4. Now, if we use the chain rule to take the derivative, we would take the derivative of the inside, which is pi over 4. When you do the antiderivative, we have to take the inverse of pi over 4, so we're going to put 4 over pi to multiply on the outside. And if we did a u substitution, we would come up with the same thing, but that's a little tricky thing there. And next, we're going to say minus 2, and the integral of x squared is x cubed, and we're going to divide by the power we raised to, bump up and divide, and then we have minus 6x, so we're going to have plus 6x squared over 2, and then we're going to have minus 4x, and we're going to evaluate all this between the limits of integration from 0 to 2, and then just simplifying out, we have our area below is equal to 16 over pi, and we have the sine of, when we plug in 2 for x here, we're going to end up with the sine of 2 pi over 4. Okay, and then we're going to have minus, we plug in 2 for x again, we have 2 cubed, which is 8, times 2 is 16, so we're going to have minus 16 thirds. And then we have 2 squared here, which is 4, times 6 is 24 over 2 is 12, so we'll say plus 12. And then minus 4 times 2 is 8. So minus 8. And just kind of working below, simplifying as we go, the sine of pi over 2 is 1. So we're just going to have 16 over pi, and then we're going to have minus 16 thirds plus 12 is going to be plus 36 thirds, and we're going to have minus 8, which is minus 24 over 3. Now what happened to this 0? Because we were supposed to take the whole function of 0 and subtract out from that, right? Well, if we put in sine of 0, which this would be here, that will be 0, then all these other things will zero out. So we're zeroing out everything, so that's going to be right. And so according to the standards of the AP Calculus test, without simplifying, we have finished right here. But if we just continue on to the logical conclusion, and we want to simplify those like terms and those thirds, we're going to have minus 4 over 3. Okay, so that's it. A little involved. The tricky part to me was anti-differentiating this 1/4 pi x, cosine 1/4 pi x with that inside there. Okay, next, write but do not evaluate an integral expression that gives the volume of solid when r is rotated about the horizontal line, y equals 4. So we have this horizontal line, y equals 4 up here, and we're going to wrap it around this way. Okay, so that's going to be y equals 4, and we're going to get a three-dimensional shape which has a rotational orientation. And so for this, we're going to use something we call our washer method. Okay, and that's going to be volume is going to be equal to the integral again from 0 to 2. Now, we have to do one more thing here when we rotate, and that's multiply by pi. So there's the pi out front, and we have, now in this case our outer function is going to be our f, because it's farther away from the axis of rotation, right? So we're going to have, our distance here is going to be 4 minus f of x, and we are going to be, that's going to be our outer squared, or big R squared if you do it that way. Subtract out, we're going to have 4 minus g of x, and we're going to square that, and that'll be dx. And then just kind of writing it all out, we have pi integral from 0 to 2, we have 4 minus f of x, which is 2x squared minus 6x plus 4. Okay, and we're squaring all that and subtracting out 4 minus g of x, which is cosine 1/4 pi x, and we are squaring the little r as well, and then we'll bracket here dx. So that's a write but do not solve. So that would be a highly decimalized answer. So that's part B. Last, part C. The region R is the base of the solid. For this solid, each cross section perpendicular to the x-axis is a square, right, but not evaluated an integral expression that gives the volume of the solid. Let's go back to the drawing and just see what that's going to look like. What you're doing is you're taking this shape and you're making a square that comes out perpendicular like this. And so you're going to make a three-dimensional shape that has these sharp squared edges as we go throughout the shape. That's what the thing is going to look like. So we come back here, and a formula that would be important for us to know is that the area of a square is equal to the side times itself, or s squared. So let's go ahead and get that going. We have our volume is going to be equal to, again, we have the limits of integration from 0 to 2. We're going to have g of x minus f of x and we are going to square all that times dx. So now it's really just a matter of writing it all out as we've done earlier. So we say, okay, 0 to 2, we have g of x, which is 4 cosine 1/4 pi x minus f of x, which is 2x squared minus 6x plus 4, and we are going to square all this here, and then we put dx here at the right. And that's it. So good luck. I hope this has been helpful to you. Good luck with that AB test, AB calculus test. Thanks for viewing.